If you drop a bowling ball and a feather in a vacuum, they hit the ground at the exact same. But what happens if we race them down a hill? We have a solid box, a solid sphere, and a hollow ring. The ramp allows for perfect sliding, without kinetic friction. If we drop them all at once, who hits the bottom first? You might think it is a tie, but physics has a favorite. The box crosses the finish line first. The marble comes in second. And the ring finishes dead last. To understand why, we have to look at their energy. At the top of the ramp, they all have the exact same potential to fall. As they move, that energy converts into kinetic motion. Because the box doesn't rotate, 100% of its energy goes into moving forward. But the marble and the ring have to roll. Rolling costs energy, and that cost is determined by torque and inertia. Torque is the rotational equivalent of force. It makes things spin. But objects resist spinning. This resistance is called the moment of inertia. Inertia doesn't just depend on mass. It depends on where that mass is located. Because the marble is a solid sphere, its mass is constant. It takes very little energy to make it roll, leaving plenty of energy for forward speed. But look at the ring. All of its mass is pushed as far away from the center as possible. This gives the ring a massive moment of inertia. It is incredibly stubborn. It has to spend almost all of its potential energy just to get spinning, leaving nothing for forward velocity. The winner doesn't depend on weight. It depends entirely on shape. This has been your Sprint Zeal Physics Moment.